And welcome back, and over to you, Siri.
Yeah, so before we start, I would like to just say that if anyone has problems with logging into new services that we are making, getting a fade open IDP account will help with that, and we have written something about that in the HackMD. Yeah, so I can just start. I have some pre-recorded slides. I hope you hear it fine.
I'm going to talk about the NIRD Toolkit. And first, we will have an overview over the service, and then we will do some demos of particular types of services in the NIRD Toolkit that you can choose. So, NIRD stands for the National Infrastructure for Research Data in Norway, and it is structured as a large storage cluster, and it's connected to the other Sigma 2 services in various ways. And we have a connection to HPC since the NIRD storage is mounted on the HPC login nodes. There are also other services that we have on NIRD, like the NIRD archive. But today we're mainly talking about the data analysis, visualization, and data processing services that we have on the NIRD Toolkit. So how do we apply for a NIRD project? In this course, we already have a NIRD project. But just to give an overview of how you can apply for a new NIRD project. So employees and students from Norwegian universities and colleges can apply. Researchers from independent research institutes with projects funded from public grants. There are also other possibilities. The minimum project allocation is 10 terabyte. So this is for projects that needs large amounts of storage. And here's a link to the Sigma 2 pages where there are more information. And just to refresh, if you want to transfer data to and from NIRD, NIRD has login nodes called login.nird.sigma2.no, and you can log in using SSH. And the NIRD projects are accessible on the login nodes of HPC like Saga, Fram, and Betsy, but it's not. The NIRD projects are not accessible on the compute nodes. So you can find the material for the course if you log into NIRD and look at /projects and then the course number. And the path to find where the NIRD projects are mounted on Saga is written here. So this storage resources on NIRD has a total capacity of 12 petabytes. The data is secured through geo-replication, so that we have replication of the data in 2 separate locations for most of the projects. And we have daily snapshots for the last 7 days and weekly snapshots for the last 6 weeks. And that means that if you have made a change to the data which was unwanted in that period, you can go back and find the previous version of your file in the snapshots. So yeah, NIRD is considered a data-centric architecture, and it has 2 sites, one in Tromsø and one in Trondheim. And for most projects, the data is replicated, so it exists on both clusters. But the project has a primary site, so some projects are mounted on to the Framlogin, and some are mounted onto Saga and Betsy. And there is a service platform that the NIRD Toolkit is running on top of. And you can see that there is one service platform on each site. And what do we mean by the NIRD service platform? It mounts the large fast disk so that the intensive I/O operation can be done directly on a large pool of data without staging the data. And it is a Kubernetes-based cloud infrastructure. It ensures high portability of the tools and reproducibility of the results through containers. And so that means the software that we have is managed using container images. And it allows pre- and post-processing analysis, data-intensive processes, AI and machine learning tools. So on the service platform, we have the following resources available. We have 16 NVIDIA V100 GPUs on each site. As you can see, there are more memory on the Trondheim side of the service platform, and that the number of CPUs are much lower than what we have on the HPC systems. That's why it's mainly post-processing and pre-processing that is done on the service platform. Yeah, and the NIRD Toolkit on top of the service platform is on-demand computing. You access this through the web, and it looks like this. We have at the moment these tools available, and we will demo 6 of them. We will demo the deep learning tools, desktop Vnc, Jupyter, Jupyter Hub, MinIO, RStudio. And at a later time, we can demonstrate Spark if that is of interest. So how do you get started with the NIRD Toolkit? If you have a NIRD project, the NIRD Toolkit still needs to be enabled. It's not enabled by default, so the project leader asks sigma2@jurinet.no, and we grant a default quota, but it can be increased based on the project needs. So here's just a slide about the NIRD Service platform orchestration. So this is how Kubernetes works. We have some master nodes that has scheduler and other control mechanisms. And then we have worker nodes where the containers with the user-facing services are running. And so Kubernetes can be called platform as a service. It gives us a way to automate deployment, scaling, and management of services. Kubernetes has a concept called a pod. And in a pod, you can have containerized applications, which can talk to each other, and also volumes, which is how Kubernetes contacts the storage. So that's called persistent volumes. Yeah, so in our case, the NIRD Toolkit is one of the services that we provide on top of Kubernetes. And everything above the GPFS in this graphic is what we call the service platform. The GPFS is the storage file system that we have on NIRD. We also have some other persistent services that are project-specific services. That project can ask if they have a web service, for instance, that they would like to have. And the NIRD Toolkit is possible to enable for all projects. And here we have a brief overview over how the components of the NIRD Toolkit are talking to each other. So the users will see the interface, user interface of the NIRD Toolkit, and they will also be asked to log in via dataporten. And dataporten will login will check against MAS, the administration system, to check if the person is actually a member of the project. So this connection is very important. It makes the connection between your dataporten ID and your area, project area on NIRD. The other potentially interesting part is the Helm chart repository. This is open source, so you can go and see how the service is set up using Helm charts. And Helm charts is a package manager for Kubernetes. And there, in right next to this repository, there's also another repository where you will be able to find the Docker files, and so that you can see how the Docker images were made and which software are available in the images that get started when we start the service. A little bit additional information about the structure of the NIRD Toolkit. The toolkit operates with the REST API. It interfaces with Helm way of deploying the services, and we have set up continuous integration when we want to make changes to the services, and that is done via GitHub Actions. And here is just a small example of what the resource in Helm can look like and how it picks up names and versions that you choose. And yeah, since the services in NIRD Toolkit is based on Docker images, it is also possible for users of this service to create custom Docker images and add them as a replacement for the Docker image that we provide. And the best way to do that is to start from one of the base images that we provide. And here is an example of a Dockerfile. This example is a little old, so the image we should start from should be more recent than this one. Quay.io is a repository for Docker images. So we have our Docker images publicly available, and you can pull such an image. This line, it pulls the building block of the previous Docker image, and then in this case we want to add Vim. And how do you install system packages will depend on what kind of container image you're basing it on, which you can find out from an earlier Dockerfile. Yeah, so in this case we can run apt to install Vim. In order to install packages that are not system packages, we have an example for a Jupyter service and the user called a notebook. And then you can run pip install to, for instance, install scikit-learn. After you have created a Dockerfile like this, you can build the Dockerfile and then push it to a repository. You will have to give the Docker image a name at the repository, and then you can specify that name in the advanced configurations in the NIRD Toolkit. And we will later demonstrate how to do that. We are now going to the workshop part of this course, and it's important to remember that when we are all of us going to start services at the same time, and the quota that we have set up for the course is not large enough that everybody can choose a large machine type. So we have a machine type called base. And it creates services that has access to 1 CPU and 1 gigabyte of memory. So if everybody chooses the base type, then everybody can start a service. It is important to remember that you only upload files that can be shared with everybody in the course, because the NIRD Toolkit application will be connected to the project storage, and the project storage is accessible to everybody in the project. And in this case, the project is the course. And if you would like to try some of the examples that we have in the project area, make sure that you make your own copy of the example file and then start working on them. So if you want to make edits. And there are some best practices that it would be nice for you to know about. Mainly, there are 2 things that I would like you to remember in today's course. When you are not actively using your service, stopping the service will be highly appreciated. This means that other people can use those resources. Also, if you would like to start with more than one service, start the first one and then use it for a while and stop it, and then start the next one that you want to try, so that you don't have 2 services running at the same time. addition, since the NIRD Toolkit is based on containers, then files that are stored outside of the persistent storage will be lost on a restart of the service. Like I mentioned, the persistent storage connects to NIRD, but everything else that can be available in the container will be lost on a restart. It will go back to what it was. So you can store the files in the paths that points to the persistent storage inside the container. And now we get to the demo part of the course, and I hope the overview will help you understand a little bit about what is going on behind the scenes when we do the demo. But it should be possible to just run a demo without knowing how the service is set up behind the scenes. And each of the demos that I'm going to run is self-contained, so some of the information will be repeated. And the demo videos will be put on the documentation pages of NRIS, and they will be available after the course, so you can watch them again. Also, before we start, I will let you know about the NIRD Toolkit documentation. So the first link is a short description about the NIRD Toolkit and how to apply. The second link is where you find the documentation for each service. And here are some other NIRD Toolkit resources that I'll just go over briefly. So this is the link for the actual NIRD Toolkit. It's located at apps.sigma2.no. And you will have received an email with an invitation link to a data button group. So if you first accept this invitation and then go to apps.sigma2.no and click on login, I hope you will see all the resources for the course. Like I mentioned, we also have the help charts, if you're curious about the services themselves. Kallhovd is a software if you would like to interact directly with the service using the Kubernetes kubectl. So Kallhovd helps you log in via data button to do that. And Quay, here's the link for the repository for the images. Yeah, your user profile in MAS is here. And in min side in databutton.no you can see which group you are a member of. And you can also find your data button ID, which can be useful for the Jupyter Hub example. And so I'm going to leave this up, and then we will start the demos soon.
Yes, so yeah, so everybody can go over to the NIRD Toolkit and see if you get in and see the resources we have. And if you don't see them, let us know. And there has, like we've seen, maybe you will have some trouble accessing the service you create. So having an OpenIDP, fade OpenIDP, can be very helpful to run the examples. Otherwise, Like I said, all the demos will be uploaded, so you can watch them again when you have gotten an open Fada IDP, if you can't make it work right now. How are we with time? Should we run one example before the break? Tanya?
Yeah, Siri, just a moment. Yeah, we can have like 11:30. You have time until
Oh yeah, okay.
past 11. So
yeah, then I think we have time to run 2 examples. I'll stop share this one. Yes, okay. Yeah, so before the break, I think we will go through RStudio and then Jupyter Hub. And these have been demoed before, and after the break, we will have a couple of new demonstrations. Okay.
Kit, and now we are going to start an RStudio service. So first you get to the overview page and see that there are some general information about what is supported, and there's additional documentation. Now we go to the installation page. And here we see that we should give the application a name, and we will have a URL on the format including the name of the course, and we can authorize the course participants so that everybody who is in this data button group can access the service. And in order to be able to store our data to NIRD, we add persistent storage. So anything that's stored outside of the persistent storage will not be kept if the service is restarted. And we choose the suggested machine type, which has 2 CPUs and 2 gigabytes of memory. And there are some additional things we can add. So if we need debug mode, and here it says which Docker images we are using. They are located at the repository Koi.io, and other Docker images which are based on this Docker image can also be you can change it into your image as long as this image suits the package. But we are just going to install. And it's initializing, and you see that the volume has been mounted to a specific path inside the container image. And now the service is running. So we go to the service and we log in with Fada, which we configured. And since this is a new service, we need to accept. Interesting. So I already did some testing, and it was remembering some of that. Let's see if there is a history. No, the history was not available. So here we have the RStudio environment, and the RStudio console is suggesting that we do a demo. So we start by doing that and see what turns up. So the demo is a list of, there is a list of demos available, and there are a way to list all the available demos. So we add this one. So most of this was already there before. So now we select a demo to run, and we decide that we want to run the graphics demo. So then and don't really know R. There is a help button here that links to the documentation, and here you can search for demo, and it describes how to call the demo functionality. And here's an example. This one, for instance. And so since I wanted to demo the graphic package, and so that's also the name of the package. And I want to have ask equals true, so that it will ask me to go to the next demo. Oh, and I misspelled graphics. Oh, that wasn't the problem. The problem was the package was not written correctly. And then you just check to see the plots in this demo package. And if you scroll up the console, you will see which functionality was demoed. So that's something that's interesting. And later when you try it yourself. And then you see that this one has different ways of plotting statistics that might be relevant. The level of interest in R has been increasing in 1996 apparently. And we can decide that we want to export one of these images, so we can save it in the image format we choose this time is PNG. and the directory, we need to go into the data folder because this data folder is connected to the course. So in the course folder, we choose that folder, we give the name rplot and then save it. And then we can go check the file, see if it's been saved. And it has. So this is very basic functionality of R. And I wanted this demo to be short. So that's it. Thanks for listening.
Yes, so in the interest of time, I'll just go right over to the Jupyter Hub example. Yeah, and let us know if you see anything and if you can start any services.
Siri, as you are in this interface, do you know the difference between Jupyter and Jupyter Hub on these two links?
Yeah, so in Jupyter, you will get one Jupyter Lab. And if you put in your group that you have this advanced, these authorized groups, if you put in a group that you share with your colleagues in the project, everyone can use the same one, or you can have one each. For the Jupyter Hub, it's more organized. So it's good for when you have courses, but also if you want to collaborate. And that's the one I want to show now. Yeah.
This is the NIRD Toolkit. And now we are going to start a Jupyter Hub service. And here you see the overview page. And this is a Jupyter Hub with a multi-user data button integration. And over here you see that there is some documentation. And we can give the hub a name. And you see that it will construct a URL where you can find the service. And it is possible to authorize a group to be able to log in to the Jupyter Hub. And all the data button groups that you are a member of will show up in this list. If you are organizing a course for students, we advise that you make a new data button group for those students. And that way students are not a member of the original data button group for the project, because this group for the project is and what the project member is using to install new services. So here we see that if you are a member of this course as a service group, you can install services. And so we are not going to authorize this group. We authorize this other group, and I have set up that my guest Fade OpenIDP account as a member of this group, so that I can show you how it works. We will come back to this when we look at the hub control panel. But you can add as many groups as you like. Next, we need to select a persistent storage in order to save files to the NIRD project area. This one connects to the project area of the course. And we choose a notebook type. And here we see that each student will have one CPU and 1 GB of memory for their notebook. And we also assume that there will be less than 200 users. Then, showing the advanced configurations, we choose Jupyter Lab as the layout for notebooks. We add that the user home directories will be stored under data button home subpath in the project area on NIRD, so that it will be persisted. And we will add some shared data here. That can be shared between all the users. And in our case, we have a folder called course demo. And the subpath you supply here needs to exist on a NIRD inside the project. We can input this folder as read-only if it is, for instance, input data that the users should not change, or we can make it so that the users can change what is on this path. And those are the configurations we need to make. So now we install the service. And now the hub is initializing. And here you can see that there are a list of recent events with some behind the scenes information. And if something goes wrong, it can show you errors here. And now the hub is running. And this is the URL where we can access the hub. So we go to the hub, and you will see the sign with the data button login. And I choose my UIB account, which is a member of the NIRD project. And since this is a new service, you need to accept that the service gets the following information. And now the hub is starting up. And we will get this Jupyter Lab interface. and a notebook that is connected to my user. Which was fetched by getting my data button ID and creating a folder using that ID. So going into a terminal, just to show you how it looks inside the container. So I have this home directory. And if we look over here to the various options, we see that there is a hub control panel, and there is an admin option. Since I started this hub, I am the admin. And here you see an interface where you can add more users. And we see that there is one server that is connected to my user that is already running. In another browser, I will now log in as my guest FADE OpenIDP user, and this will be our student. And when I paste the link to the hub, I get to the data button login here as well. And a person that is not in the authorized group would not be able to start the Jupyter Lab from the link to the hub. And we see that this lab is connected to the FADE OpenIDP ID. And in the hub control panel, we see that this user does not have access admin right. And going back to the Jupyter session, we see that the student has access to the shared directory we configured, and also to a folder named after their ID. All data that the student adds in this folder ends up on the NIRD project area of the course, since we configured it to do so, even though this student is not a member of the NIRD project. And another thing, if you prefer the classic notebook over the Jupyter Lab, you can start one from here, and then you get this view, which is the classic notebook view. So that's for the student, and now we go back to the admin user. So going back to the hub control panel of the admin user, we see that there are no two Jupyter Lab sessions running. We can also see that the admin user is allowed to authorize itself to enter the server of the student. So now we are again in a session for the student, and everything the student has access to is on the NIRD project anyway. So going back to the control panel again. for the admin. Under Edit User, what you can do here is to add the user as an admin, and you can also revoke admin rights for the user. And if you stop the server, it will delete the container that is running the server. And now it is stopped, and then you can start the service. It will create a new one. And if you decide to delete the user, it will also stop the container that is running the server for this user. As long as the student is still a member of the authorized groups and knows the link to the hub, they can still start a new Jupyter Lab session for their user. So deleting this user in this view is not final. So after the course, if you're organizing a course and it's finished, and you then need to revoke the student's access to the authorized group, as well as deleting the user from the hub control panel. So I think that was most of the administrative tasks in Jupyter Hub. And now I will show some plotting in a Jupyter Lab example.
Siri, can I have a question to help answer something on HackMD?
And
Oh, sorry, it's a recording.
Yeah, no problem. Yes.
Yeah. So you showed very clearly how you would share your projects that you create and add users. So the specific question I have on HackMD is, how do you get access to somebody else's project? Like, is it something that you could find here, or how does that work? Do they have to apply for something?
First of all, if there are two different project leaders, both project leaders has to agree. And then we can create persistent volumes across projects if it is everybody is okay with that. And what we usually recommend is definitely to add that as a read-only into the other project when we are now talking about two different NIRD projects. Does that answer the question?
Yes, so I'm going to type that in. If there's a follow-up, I can ask later.
Okay. Yes.
we can go to the files directory. And I have some example files here. And these examples I got from the matplotlib gallery. So if you search for matplotlib, they have a large gallery of examples. And whenever you want to plot something, you often don't need to do it from scratch. You can take an example, and all of these examples are also in a notebook format. So you can just upload these examples directly and try them out. So I'm going to start up one of these notebooks. And here is an example with interpolation. And there are some cells of code in this notebook example, and we should run them all. So this one specifically, it's selecting methods for interpolation and setting up a grid that's just 4 by 4, and then it's choosing the methods for interpolation and then showing the results for all of them. So we can run this cell of code, and you see that here are several ways. So you have the non interpolated example, and then yeah, various functionality that is available. So that was the first example, and when you close the notebook, you would usually want to close and shut down the notebook just to save it. And we go for the next one. So this one is also very simple. It's just a nice way of plotting a scatter plot. And I basically just wanted to show this to show how nice Matplotlib can present data. Some of the basic functionality of the Jupyter Hub, and we will now go back to the NIRD Toolkit. We see that the hub is running, and since we are finished with the demonstration, we would like to delete the application, and then we see this warning. And this warning is important that we remember that any changes that has been made outside of the persistent volume folders will not be saved after you delete the application. So only the data that is available on NIRD will be still there if you create a new service. And I go back to my application page and see that only the other running services that I have is still available, and the Jupyter Hub has been shut down. So yeah, thanks for listening.
Yeah, so now we'll go over to some different ways of adding other software into the containers.
Now I'm going to talk about how we can customize a Jupyter notebook so that it has fewer dependencies. Usually what we recommend if you want some other software in a NIRD Toolkit service is to start from the Docker image that is the default and then build on top of that. But if that is difficult due to the dependencies that are already in the image, we will now show another way of customizing the notebook. So the NIRD Toolkit Jupyter and Jupyter Hub extends the official images, and those Docker files can be found at github.com/jupyter/dockerstacks, and there are several options there. And now I will go through a kind of a recipe on how to make a custom image with less dependencies than what we have in the NIRD Toolkit today. So in order to get some of the customization that is needed, you can start by making a fork of our repo Helm charts Dockerfile. Then clone that repo onto your computer. So we can go through the ones that are there, and then if you find one that is small enough for what you want, you can start editing the file you want to change. And we have made one that's based on the base notebook from the Jupyter Docker stacks. But it still has some of the this Dockerfile still has some of the software that we have in some of the other services, but you can remove anything that is not directly Jupyter related, probably. And the next step is to build the Dockerfile locally. And to do that, you need to check that Docker is installed on your machine. Then you change directory to the path where you cloned the repository. And then you can just have the build command, and the T is for the tag. And then you give it a tag name, and then this dot is that we are in this folder, and this folder has a Dockerfile in it. So that's why we only specify the dot here. The building the image takes some time, and when it is done, you can push the Docker image to Dockerhub. And then you, in order to do that, so that the image you just made can be publicly available, you need to sign up or sign in to Dockerhub. You also need to be logged in locally on your machine. In order to be able to push the Docker image, you need to give it another tag. So this tag is already attached to the image you made, and then you give it another tag. And it's important that in this tag is your username, so that you will get and be able to push it to Dockerhub under your username. And then, yeah, just the command docker push username, and then the name you choose for the image that you have made. And after you pushed the image, you can check that it's actually there on Dockerhub. And when that's okay, you can go to the NIRD Toolkit. And here in this example, you can then start the Jupyter Hub in the NIRD Toolkit with the image you just created. and the way to add it is to change the user image under advanced configurations to and the name of the tag that it's called on Dockerhub. And since this is Dockerhub, you don't need to specify which repository you are referring to. In the case when we have our images at Quay.io, you need to specify that, but Dockerhub is the default, so you don't need to specify that. Yeah, so that's what I wanted to say. We have another video where how to set up the service using a image is explained more interactively. So yeah, have a look at that, and thanks for listening.
Yeah, and we'll go right to that example now.
So this is the NIRD Toolkit. And now we are going to show how to choose a custom Docker image for the Jupyter Lab sessions of the Jupyter Hub. And we go to the installation and we give this hub a name and we authorize who should have access. In this case, the people in the course, and the persistent storage is the NIRD storage of the course. And in this case, under the advanced configurations, we have the user image, which is pointing to a specific Docker image hosted at Quay.io for Docker images. And we are going to choose a more recent one that we have been working on. So we go to Quay.io and we see that in the repository we have some tags. So here is a tag that we want to use. And going back, now we have this link that we add, and then we can start the service. And while it's installing, we can go have a look at the repository for the Docker files, which the Docker images are based on, and they are hosted at GitHub. And here is an example of how we create these Docker images. We start from a similar image to what we want. Here is one from Jupyter. And then we do some installation using both Conda and pip. And then we build a Docker image using Travis CI, but you can also build it locally, and then push it to a repository like we have done. So what you would normally do if you want to change something with the image, you make this kind of from statement and then your additions, and then you build. So going back to the hub, we see that it is now running. So we start one lab session and sign in with Dataporten for my UAB user, and we accept, and then it starts up. So this image is not quite ready, so there is some things still needed to be fixed. And just to have show you another way of installing software, we see that the Python that we get in this terminal is it's located in conda /conda/bin/python. And if we, for instance, do pip install vtk, we have installed it now, and then just checking that it's there. And again, if we then go to the hub control panel and stop my server, which would stop the container running the server and then start the server again, you will get a new container. And going here, you still see that you have the same Python, but import vtk now says that vtk is not installed. So if you do your installations in this way, you need to have some kind of a record of what you want to install. So that was what I wanted to show. For now, thanks for listening. Yeah, and now I will show an example with TensorFlow.
Siri, can I have a question?
Yeah, sure.
Is it possible for foreign collaborators to get access to one of the projects? Let's say a person without a FID account, for example. Is there a way for that?
Yeah, so I think I answered that in the HackMD.
Okay.
So anybody can create an open ID feed guest FID account. You only need an email to do that. So foreign collaborators can do that. And they can access the service if they get an invitation link. The data button invitation link controls if you can set up access the service if you configure it that way. So I guess there is a follow-up right now. So if you want an actual MAS account for your external collaborators, I think that is also possible if you are the project leader. But the person also needs to apply for a MAS account in that case. So in the Jupyter Hub example, anyone who has an open IDP and the invitation link can get a notebook up and running without being a member of the NIRD project itself. Okay. Yeah, so I'll keep going. Do we have 20 minutes before a break now?
Yes, Siri. Yeah.
Yeah. Then we'll go with the TensorFlow example.
So this is the NIRD Toolkit, and today I'm going to demo the deep learning tools. And here you can see that there is some overview over which packages are installed, and I'm going to mainly look at TensorFlow. And the deep learning tools are GPU enabled and takes the form of a Jupyter notebook. So we go to the installation. And while we are waiting, I will show the example that we will go through today. So at the TensorFlow web pages, there are some tutorials. So I'm downloading, I'm going to download it in here. So here we are. I'm going to give the application a name. And I'm going to invite everybody in the course group. So this is a Dataporten group. And anyone who has had the invitation to this group should be able to log in to this service. We have a project space that is connected to the course NIRD project, and then we select the persistent storage, and that means that we get access to the file system on NIRD at that point, so that we can see what's in the project. And then we need to choose a machine type. And since this is a course, we don't have access, we haven't given this course access to a GPU resource. So we need to choose another machine type. And the example we are going to run requires more memory than 2 gigabytes. So we're going to choose this one with 8 gigabytes of memory. And then we can go to the advanced configurations, and here we can choose which Docker image we want to start the service from. And here we have a default, and in this default we have TensorFlow version 1.15. So I'm going to demo a newer version that we are working on, but it's not quite ready yet for so we have it here. It's still on Quay, and then we have another repository now where we put the new images called NIRD Toolkit. And I'm going to select that I want it to look like a Jupyter Lab, and then I'm going to install the service. And while we are waiting, we can go back to the example. And the example we're going to go through is a guide that trains a neural network to classify images of clothing. And we choose this example just to check that the TensorFlow 2 is behaving as it should be on NIRD Toolkit. And I can, so what it's doing, it is taking a data set of black and white clothing images and putting them in 10 categories. Let's go back and check how the status of the service is now. Yes. So recently it has been sometimes saying that it's running even though it's not quite ready, but we can check. And we will be asked to log in via Feide also for this service. And since this is a new service, we need to
confirm that it's fine. And then the Jupyter lab service is there. And then we can upload a file. And we have this one that we just downloaded. So we can have a look at the file. Yes, and here we have a license for this file saying that this is an MIT license, so it's fine to use it. And let's go down. We can start seeing if what we have is working. And since we did not specify a GPU and TensorFlow expects that there is a GPU, there is one more thing we need to add before we can run the example. And that is to say that TensorFlow should not expect the GPU. And then we run that. Okay. And we'll hope that it's not going to be too much of an issue. We see that we have TensorFlow 260. And here's the data set again. Yes, so first we download the data. And it will give us 4 NumPy arrays. So the dataset has been split into some images used for training and then corresponding labels used for training. And then we have the rest of them for testing that the model is doing well. So making good predictions, we can do that against the test images and the test labels. And the labels means different types of clothing, and the class names are here. Then, yeah, every time we want to be sure that it can be run. So I'm going to check that the data was loaded correctly. All the data is there. And then we can show one of these pictures from the training set. So all of these images are very coarse, but since there are, that's a good thing since there are so many of them. So it won't take too much time to run the model. And then we scale the values into a range between 0 and 1 before feeding them into a neural network model. And then we can verify that the data is still recognizable. And then we have 25 of the images displayed here. So now we come to the building the model. And I'm not going to go too deep into this. The example is there if you want to check it out more. Oh, did I not? I thought I did maybe it didn't pick up this CUDA invisible devices. So let's try again. Yes, and now it made this model, and then we can compile the model. And then fit the model to the training data. So now the model is training, and there are some accuracy metrics that is being displayed, and those are comparable to what was in the example before. Yes. So now we have a trained model, and then we can compare how the model performs on a test data set. Yes. So there we have a test accuracy. And yeah, so here's some information about what the test accuracy means. And now we have, now we can make some predictions. By making, yeah, this. Now we put the test images in. And then we can see the first prediction that we got out of the model. And so the prediction gives an array of 10 numbers representing the labels, and then we can check which one is the highest confidence value, and that's the label 9 for the first test image. And then we can check that this is the right one because we already have also test labels. And yes, so the prediction of the first test image is 9, and it should be 9. So then we make some more plots and we verify some more of these predictions. Just looking at 2 of them. First, this one, which is very confident that this was an ankle boot. And then we have this one. And here it is displaying the wrong output compared to what the test label is saying. This training set thinks that this is a sandal, but it's really a sneaker. And then we can check some more. Yeah, so here we see that for most of these images, the model was able to get the right label, and some of them are a little bit, they have some other suggestion too. And there we have the one that thinks it's a sandal. And I think that's the main takeaways from this example. And we see that we can make TensorFlow work even if we have a service without a GPU. And yes, so that was mainly what I wanted to show here. Tensor, the deep learning tools also sets up a tensor board and machine learning flow service as well, and those I will demo another time. So now we can delete the service since we are done using it for now. Yes. So then the service for the deep learning tools is no longer here, and only another service is in the same namespace is here. And while you are working in a project, you can see your applications, but you can also see all applications that are running in the project. If some other people in your project is running an application too, you can check that out. You can also look if there are any stopped or failed applications, or you can just click on all applications. Just to get a good overview over what is going on in your project. Yeah, that's all I wanted to show. Thanks for listening.
Thank you, Siri. Do anyone have any question? Sabri, do you have something from Hackamd?
I'm managing some of them, but I will need a lot of help later on. So this NIRD, when you have this continuous persistent storage, where is it? Is it like a local drive do we have, or is it a cluster partition? How fast was the question?
Sorry, one more time. I was reading the HackMD. Yeah.
The persistent storage,
Yeah.
how big is it, how fast it is, and where is it located?
Okay. Yeah, the persistent storage points to NIRD. So what I said in the overview of NIRD, that's what it is. It's a GPFS file system. The total of NIRD is 12 petabyte, but you only have access to your own projects. And yeah, so it should be as fast as it is on the login node, because the login node is also a container for NIRD. So yeah.
Okay, so the other questions I think you are mostly answered about GPUs that you don't need reservations, so you just come and book it. It seems. How do you know if there are GPUs available that I can use? Is there some command or some monitoring going on?
Yeah, we have monitoring, so you can ask us if you're. So what I would suggest in the beginning is, first of all, you need to have a quota for the GPU. So in this course, we don't have a quota for the GPU, so it will not start anything. But if you have a quota for GPU, try starting a service. If it doesn't work, then it might be that all of the GPUs are occupied. And then we will have to take a look.
Then there's another question that we might need some time for that. Maybe so is there so how would one use multiple environments on notebook? Do you have any, let's say, multiple Conda environments? Is there any answer on top of your head? Or
I have tried it, but it's a long time ago. So we have at least 3 options for Python. There's one called minimal Conda, one called just Conda, and then one that's without Conda. So you can change between kernels. But if you want something in addition to that environments, I think it's also possible, but then you need to have those environments in your project area on NIRD, I guess.
yes, so we could change the kernel. So in the Dockerfile, do you have any tutorial or details about how you would do that in a Dockerfile? How do you activate multiple environments?
Yes. So I guess if you look through the Docker files that we have in the GitHub repo, there is at least one option on how to add this minimal Conda. It's set there. So you can probably, if you want to make your own service, you could do something similar for another one in addition to those.
Yes, Dania, how long do we have? Do you have any?
We have time until 30. So Siri, do you have anything else to show?
12.
No, we have 30 minutes more. So I was thinking that we can be here if anyone have questions and go through the HackMD.
Yes. So there was one question about the VNC and NC view.
Yeah.
And the short answer to this is that the NC view is installed in the VNC container. And I have a demo video where I very briefly do that, but mostly it's focused on MATLAB. But I could run that example too, if people are interested in visualizing through the desktop VNC container option. Maybe I should just do that.
Yeah, please go ahead.
Let's see.
and we are now going to start a desktop VNC service. And the desktop VNC service is based on a container image of Ubuntu. And we go to the installation page. And we choose a name for the application. And you see that this name will also correspond to a URL where you can find the service. And since we are working on our course right now, we might want other people to be able to log into the service. So we authorize a data button group with the members of the course. And we also need to select persistent storage. So this persistent storage is the connection to the project on NIRD. And we have also added the possibility to connect the MATLAB executable. So that is one way to add software into the service. And in this case, since we are trying to demo MATLAB, we choose slightly more memory. And for the machine type, so now we have 2 CPUs and 8 gigabytes of memory. And then just to show that the only advanced configuration that you can change in this case is that here we point to the Docker image we are using as a basis for the service, and as long as the Docker image corresponds to something similar to what we have here, you can add a different Docker image. So you can add software to this service, but we are just going to install, and this might take a minute. And while it's initializing, we see that the mount points of the storage is specified here, so we can find it when we go into the service, and the service is now running. So we connect to it and we log in with Veide. And since this is a new service, we need to accept this service. And we're inside of a Vnc desktop environment. So we can open a terminal and writing bash is just making it easier to move around, and the connection is a little bit slow. So we go into the mounted folders, and before we start MATLAB, we need to source or export the license. So I have put that into a file. So that we just run this, and then the license is exported, and then we can start MATLAB. So starting MATLAB, and MATLAB will be selecting software OpenGL rendering, since it's not connected to GPU, and that will make the rendering of large data sets slow, so it's recommended to either just use scripted MATLAB and also downsample before you try to display. So we are going to do a very simple example. Creating a small plot. So we're making a mesh to display, and you can do some things to this plot. You can add a color bar, and a title. And then you can save the plot in various formats. So we choose JPEG image. And we want to put this in the course folder, so then we can save it and look at it later. So let's close MATLAB. And can first check that we were able to save the file. And here it's the MATLAB test file. So then we can quit MATLAB. And I also wanted to just do a very short demo of the NC View application. So we have some demo files that we check, and this view here we have some data over the world in the NC format, and we can go through time. The time is down here, and if we go fast you can see how things change in time. And yeah, so the NC view is also available here in the Vnc container for people who like this format. And then now we want to close down the service. But first I'm just going to show you that it's possible to reconfigure a service. and you get the same options that you started with. And sometimes we create updates to our packages, and you have a list of packages here. So when you have a service for an older version, you might be asked to reconfigure it or upgrade it. And if you stop the service, you will get a warning that all data that has been saved locally will disappear. So only the data on the persistent volume will be saved and will be there when you start the application again. And the same warning you will get when you click for delete. So we will now delete this application. And then it goes to my application tab, and you can see the other running services that I have, but not the Vnc service that we just deleted. So that's it. Thanks for listening.
Yeah, thank you, Siri.